Welcome back, everyone. Today, we're diving into the world of AI security, specifically around large language models. There's a lot of excitement about what these models can do, but they also come with risks, particularly when it comes to their training data.
And when we say risks, we mean a whole new attack surface. Large language models like ours are essentially trained by digesting massive amounts of data. The problem is that data, whether from public sources or specific curated datasets, can be manipulated, either intentionally or not.
Exactly. One example of this is training data poisoning. If an attacker manages to inject harmful or misleading data during the training process, it can shape the model in unexpected ways. Imagine training a model to detect spam, but it's been subtly taught that certain spam patterns are actually legitimate. Over time, the model could start letting in real spam, compromising its effectiveness.
Lovely. And it doesn't stop with the training phase. If the model is continuously pulling in data in real time, like in RAG systems, it's still vulnerable. RAG, or Retrieval Augmented Generation, relies on external databases and APIs for its real-time responses. If those external sources are compromised, the entire system can be fed with inaccurate or even malicious information.
Right, it's a bit like opening the front door without checking who's knocking. And that opens up possibilities for other types of attacks, like prompt injection. In this case, an attacker can subtly manipulate the inputs to trick the AI into producing harmful or incorrect outputs.
Yes, prompt injection. For instance, if someone manages to sneak malicious code into a prompt or into a public dataset that the AI references, it could cause the model to execute commands it wasn't designed to handle. This is a huge issue because models are being integrated into systems where they can access APIs, perform automated tasks, and, in some cases, handle sensitive information.
Good point. And that's why securing the data pipeline is so crucial. You can't just assume the data coming in is safe, whether during training or real-time operations. You need encryption, strict validation processes, and most importantly, constant monitoring.
Monitoring, yes, because humans are great at catching everything, right? But seriously, anomaly detection systems are key here. They can spot when something is off, whether it's a sudden change in the model's behavior or unusual data patterns coming through. Without that, you're flying blind.
And speaking of blind spots, another issue is the lack of transparency about where data comes from. We need to ensure the provenance of data, especially in highly sensitive AI applications. Was this data altered before it reached the model? Can we verify its source?
Exactly. It's not just about preventing an attack, it's about being able to trace and isolate the source when things go wrong. Provenance tracking, encryption, and role-based access control are all part of a good security framework.
And we haven't even touched on adversarial training yet. This technique essentially teaches the AI to recognize and handle manipulated inputs, making it more resilient against attacks. It's like giving the AI a tougher workout routine so it doesn't get blindsided by malicious data.
Right. Though, like any workout, it's only as good as its consistency. Regular updates to training datasets, ongoing audits, and even red team exercises where experts deliberately try to break the system are necessary to keep things in check.
Absolutely. AI systems are only as secure as their weakest point, and often, that weak point is the data pipeline. So, if you're building or deploying an AI system, make sure you're not just thinking about how smart it is, but also how secure it is.
Otherwise, that smart AI might just become someone else's attack vector. And trust me, it won't be pretty.
So, the takeaway? AI can do amazing things, but we've got to stay vigilant about security. Secure your data, validate your inputs, and always keep an eye on what your model is learning.
And for the love of everything, please assume that someone's always trying to break in. You won't regret it.